Hey, we are in the at the last segment of the volcano chapter, I should say. I finished the second segment at the caldera formation. So let's say here is the magma chamber, and as the magma chamber, as the magma empties out of the magma chamber, actually it will produce a big amount of space. So when the all the magma which wanted to erupted, uh, the whole mountain is kind of fall back into the hole, and that's how the big calderas are gonna form right here. When this area is larger than 2 miles, we call it caldera. Otherwise, if it's smaller, we call it crater. Usually these calderas are gonna fill up with water, so they are gonna produce amazing crater lakes. There is a really cool caldera right here, and that is the Puyo cone, and it's really beautiful actually. See, it's a very pretty caldera. And this here is Crater Lake. That is actually my picture. It's an amazing place to go. So if you ever have the chance, do it. The Crater Lake is about 1 point something miles wide, but it's really like actually more than 1 point something. It's 2 miles or more, but they still call it Crater Lake, even though it should be called Caldera, but they named it Crater Lake. Okay, now we are at the types of volcanoes, and this is kind of important. You have to know them because I will ask them. The first type is the flood or plateau basalt. Um, when this flood or plateau basalt forms, usually there is a hot spot going under the, like there is a hot spot on the oceanic plate, and as it goes under the continental plate, the hotspot reaches the continental plate, and as it does, it will produce a huge amount of mafic lava, basically layer upon layer, a whole lot of it. And it's going to be thousands of square kilometers. And this accumulation of mafic lava is what we call flood basalt. It's basically flood. And this slide shows you these typical flood basalts of different geologic times on Earth. The one of the famous for us is the one which is right here between Oregon and Washington State. And actually, these basalt lavas are producing amazing soil. Um, so all the Oregon and Washington organic farming is related to these amazing soils. They are usually very, very black, very nutrition rich soils, very good farming in these areas. And this next slide shows the plateau basalt of Oregon. As I said, this is very typical between the, oh, my pen has the same color. That's weird. I'm gonna change it anyway. So here, now I have red. Now, I thought I could change it. Here we are. So this here is the Columbia River, right, at the boundary of Oregon and Washington. And if you go into that river actually cuts through this amazing basalt floor. Like as you can see, this is all basalt. And if you go along the Columbia River, you don't see anything but this amazing columnar basalt. And what makes it even more cool, this area is like a geology heaven for me, for sure, because you're on the oceanic continental plate boundary also, so you have all these cool stratovolcanoes, like the Mount Rainier, Mount St. Helens, Mount Rainier, Mount Adams, Mount Hood, the Sisters. Like you can see, like as you travel through the Columbia River Gorge, and you stop somewhere right here, you're able to see 3 volcanoes this way, 3 volcanoes this way. It's one of the most amazing experience I have had actually. It's really, really cool. And then you go into the river valley, and you see these amazing columnar basalt flows, huge big waterfalls. It's a very scenic, very amazing ride. And if you want to know something really interesting, that when you start right here, this area is, because of the from the Pacific Ocean, as the clouds are coming, because of the mountain, they have to go up. So therefore, there is a whole lot of rain right here. So this area here is a mid-latitude rainforest, we call it. So you start at the Columbia River and you go in a rainforest. And then as soon as you go over the mountains, you're in a desert. So in less than an hour drive, you can see from rainforest to become a desert. You can see the oceanic continental plate boundary volcanoes, and you can also see the flood or plateau basalt right there. So it's one of the most amazing experience I have seen. Like I told you before, I think geology is just about everywhere. So, okay, the next one is the shield volcano. When you have shield volcano, we are still in the mafic category. Shield volcanoes are strictly mafic, producing mafic lava, and because of the low viscosity, they flow like water. Remember, the only thing they can produce is a very low angle, so-called shield volcano. They look like shields. So shield volcanoes, the angle of the volcano itself is like 1 degree, so it's really you know, it looks like a shield. That's why they call it shield volcano. So this is very broad lava flow. It has a central crater. The slope is very shallow. It's like a flattened shield, like the slide says. These are very long lived. They will produce lava for the longest time, and these lavas are either pahoehoe or aa. One of the best example of is the Kilauea, I think, in Hawaii. The next one is the Cinder cone. That's the third one. So the flood or plateau basalt, the shield volcano, the Cinder cone. Why is it the second? Plateau basalt, the shield volcano. I have it messed up. This should be 3. I am so sorry. I had to go back to see what's going on. So the 3 is Cinder cone, and usually they will erupt pyroclastic material. The slope is pretty steep, as you can see on this figure. It's very typical. Every single cinder cone will look like this. Usually it's a parasitic, little teeny tiny volcano, larger volcanoes. One of the best examples for this is the Paracutin in Mexico. And if you've been in California, Arizona, from Nevada to Arizona, if you go to the Grand Canyon, when you drive from Flagstaff up to the Grand Canyon, basically on the way, you're crossing the San Francisco volcanic field, and you'd be almost silly not to stop to look at those really pretty little cinder cones and all the lava and everything I just was telling you about mafic lavas. So do stop at the San Francisco volcanic field if you ever go to the Grand Canyon from the south. And if you have the chance to go to Korea ever, South Korea, I did go to the Jeju Island, where I saw all these features also, a lot of really beautiful cinder cones and everything. Okay, the next one is and now this is 4, obviously, because the 3 was the cinder cone. This is the composite cone. Along the ring of the fire in the Pacific Ocean, most of the volcanoes are going to be composite or stratovolcanoes. That just means that you have one layer of lava, the next layer is pyroclast, lava, pyroclast, lava, pyroclast. As I told you, I went up to the Vesuvio and I looked into the crater, and this is what I saw: lava, pyroclast, lava, pyroclast, lava, pyroclast. That is what we call stratovolcano. So one eruption is producing lava, the next one is producing pyroclast, and so on. It's not very much fun to be around the stratovolcano because they are more explosive eruptions, so it's kind of dangerous. They are going to be very picturesque, like Mount Fuji, Mount Rainier, Mount Adams, Mount Hood. These are beautiful mountains, but you know that they are all dormant. They can erupt anytime. All the volcanoes along the Ring of Fire, and then Indonesia, those are oceanic plate boundaries, so every single island is a volcano basically, so none of them are safe. None of them. Okay, the next one is the volcanic dome. And the volcanic dome is usually very rounded, and it's very viscous lava, rhyolite usually. So therefore the magma will not go anywhere and will build up this very typical lava dome. These are probably one or more individual lava flow, but the lava doesn't go anywhere. As you can see here, it stays right there. Volcanic domes can also be called lava domes. So volcanic dome, lava dome are synonyms. A lot of the volcanoes in Alaska are like this, because that's also like oceanic, continental oceanic plate boundary, so you can get a lot of very felsic, very eruptive lava volcanoes. Now this slide you probably want to know the most, because this is a summary of the different volcanoes. So if I ask you the type of volcanoes and their characteristics, and you could sketch it, this is what you want to sketch. This is what you want to sketch. And these are the names. See, the flood or plateau, the shield volcano, cinder cone, stratovolcano, volcanic dome, and the caldera. So, and there is the characteristics and some example which you might not have to know, but if you do, that's a good thing, really. But I will ask the types of volcanoes. And the next thing which comes up is the type of eruptions. And this is kind of interesting to know what kind of eruption can you expect at certain places. So the first one is the Icelandic type. When you have the Icelandic type, that just usually means that it's molten basaltic lava, and it flows out along fissures, like the Lucky Fissure, remember? And it's not that dangerous. The problem is the gases and the basically, especially if it's underwater. If it's Iceland, remember Iceland is mostly covered by ice. So let's say the volcano opens up, it starts to erupt, but what happens, the snow melts into it, so that's a lot of water, and because of the water reacts with the very hot lava, it actually dissipates and makes like a volcanic ash kind of cloud, and this is what we call phreatic explosion. So even though basically the mafic lava should be friendly, because of the water seeping through the hole, can make a big explosion, like Krakatoa was like that. Much bigger explosion than it would be normally. But so these guys, because of the water goes into the fractures, it actually can make a lot of volcanic ash-like clouds, which reaches the lower atmosphere, and it causes lots of problems. So this is the Icelandic type. But as a volcano, usually it's not that dangerous if it's not a phreatic, which means if it doesn't have water involved in it. The next one is the Hawaiian type. It is similar to the Icelandic type. In this case, the fluid lava will go radially, making shield volcanoes, and these are quite large. They have gentle slopes, as I already told you, and usually it's not dangerous whatsoever. And it never really have problems with phreatic explosion either. The next one is the Strombolian eruption, and usually these eruptions involve moderate bursts of expanding gases. It's more viscous, so it can have gas build up, but it's usually not that big. Stromboli is one of the most active volcano ever. It's in Italy, and it's off of the west coast. It's a little bit south, northeast coast of Italy. To me, it's a bit more south, but you could look it up, Stromboli. So it's just about all the time active. That's why they call it the lighthouse of the Mediterranean. Lighthouse of the Mediterranean. So this is the Strombolian. And the next one is the Volcanian. And the Volcanian type is named after Volcano Island, which is not very far from the Stromboli. And this is usually involves like moderate explosions of gas with volcanic ash. And this will make mixture of dark turbulent eruption clouds, which explode. But it's not such a big deal either still. This one, the Volcanian. The worst kind of eruption is the Plinian type. The Plinian type is sorry, the Pelian type. The Pelian is before the Plinian, so that's going to be the next one. The Plinian type is the some explosive outburst that will generate pyroclastic flow, like you can see it right here. This is a typical pyroclastic, and this is named after Mount Pelée in the Caribbean island of Martinique, and it happened in 1902. And so these are kind of destructive, but it's nothing like the Plinian eruption, which is the next one. So the next one is the Plinian type. This is the most destructive of all volcanoes. When you have this type of eruption, the gas is boiling out from the gas-rich magma like this, and this goes up to the as you can see, it goes all the way up to the higher atmosphere, and it makes like big time aerosol cloud which shuts the sun away, and it will have a whole lot of cold periods after the eruption and causes a lot of acid rain. So it's really, really, really bad. Plinian type is the worst. This is how Yellowstone would erupt if it did. So in general, if you want to know the main difference between a mafic and a phasic lava flow, I mean, guess which one? This is the phasic and this is the mafic. Now, the next thing we have to talk about is the volcanic explosivity index, or VEI. That is going to tell us how eruptive a volcano, how explosive a volcano is going to be. So this is important that you know that. I will even ask it. Every year about 60 volcanoes will erupt, but most of them are going to be very weak. The way the volcanologists measure how big an eruption is going to be is by the explosivity index, VEI. And these are based on a number of things which we can actually measure or observe during an eruption. So according to this scale, big eruption will not happen very often. And this here shows you the explosivity index and how much volcanic material is coming out. And this tells you the column height, you know, like the height of the volcanic column which comes out. And the classification is right here. And then the total historic eruption. And that's it. This slide shows you even better the amount of the volcanic material. So here we are. You can see Mount St. Helens was about 4. This is the 4. Here is Mount St. Helens. See, with the 1 cubic kilometer. And you can see that Yellowstone is really basically 8. So each eruption of Yellowstone basically belongs to this, the worst kind, the number 8 on the explosivity index. So just remember this. Now this slide is just for your fun. This shows you the different types of eruption. Again, this is the VEI right here. and this is the description of it, like how explosive. Like the number 8 is mega colossal. That's a name for you right there. This is gonna show how high the plumb is gonna be, how high the volcano is gonna go up. This here is the volume. So you can see that the Yellowstones are all mega colossal, and these are all ultra Plinian, which means it's really really big Plinian. And how often? This is like tens of thousands of years, and this is which volcano is that. So this is, you don't have to know, but it's kind of very very interesting. So I'm gonna stop right here and continue in the next segment.